This is a video on solving equations when there are constants and coefficients. So my first example is 3x plus 2 equals 5. We can see in this example that there are constants 2 and 5, and there's also a coefficient 3. If I look across this equation, I'll notice that there are some like terms. The 2 and the 5 are both constants, so they are like terms. So what I'd like to do is first of all start by getting my like terms on the same side of the equation. What this means is that I'll bring the 2 over to the right-hand side with the 5, and this will leave my x term by itself. So what will that look like? Well, the 3x can stay put on the left-hand side. The 5 is already on the right-hand side, and the plus 2 comes across. And of course, when it comes across, it must change what it's doing. It's on the opposite side now, so it must do the opposite thing. It was adding, and now it's going to subtract. At this stage, then, I can tidy up my like terms. So I look at my like terms and I simplify them. And I'm going to end up with 3x equals to, well, 5 minus 2 is 3, so equals 3. I'm not finished yet because my goal in this question is to solve for x. I want to get the x by itself. I want to know what it's worth. So this 3 is still a problem. Okay, so this 3 is a coefficient. A coefficient is multiplying by the variable that it's with. If I want to get rid of this 3 and bring it across to the other side of the equation, what will it have to do? Well, if it's multiplying here, it'll have to divide when it goes across. So x will stay on the left. This 3 is already on the right-hand side. And the 3, which is the coefficient, comes across and it divides. Okay, so now I just need to evaluate this. 3 over 3 means that x is equal to 1. Just like before, I can do a quick verification to check and see if I'm correct. So I can substitute this value for x into my original equation. As long as the statement it makes is true, then I know that I'm correct. Again, you can type in the left-hand side of this equation into the calculator, 3 bracket 1 plus 2, although I'm sure you can probably do that in your head as well. And it comes out as equal to 5, so I know that I'm correct. The solution for x is 1. Let's have a look now at a second example. 5x minus 1 equals 14. Bear in mind again that generally the calculations in these questions are pretty simple. And again, I kind of have an expectation at this stage that you're adding and subtracting and multiplying and dividing is okay. Really what you're focusing on is your layout of your question. And just to point out, looking back for a moment to example 1, what I want to see on your page is the lines that I've written here in purple. And maybe this verification line at the end. You don't need to write the notes in. This is just me explaining what's going on to you. But you should show all the steps along the path to your final solution. Okay, back to example 2. So I've got 5x minus 1 equals 14. So first of all, I want to get the like terms on the same side. So 5x can stay where it is. 14 is already on the right-hand side. This 1 is subtracting. When it goes across, it'll do the opposite. It'll add on the right-hand side. And now I can simplify on my right-hand side to get 5x equals 15. I'm not quite there yet because I want to get the x by itself. So x can stay on the left-hand side. 15 is already on the right. And the coefficient 5, which is multiplying on the left, comes across to the right-hand side of the equal sign and divides instead. I can now calculate my solution, and it's x equals 3. Again, it's no harm to just verify that you're definitely correct by subbing it back in. So substitute in, type in the left-hand side of your equation into your calculator. See, does it come out as 14? 5 times 3 is 15, take 1 is 14, so that is correct. So x equals 3 is definitely my solution for x. Here's example 3. 6x plus 1 equals minus 11. Okay, get like terms together first of all. So that means keeping the x term on the left and putting the constants on the right at the equal sign. Well, 6x is already on the left-hand side. Minus 11 is already on the right-hand side. And now the plus 1 comes across and changes what it's doing, so now it's minus 1. And I can work out minus 11 minus 1, and that's minus 12. Now just bear in mind, make sure that you're following the correct rules. I'm not multiplying the minus 11 by the minus 1, so I don't use the rules for signs that I would use for multiplication. I'm subtracting, so I'm at minus 11, and I take away 1, so I move one step to the left. That's why I'm landing at minus 12. Now I want to get the x by itself, so I keep the x on the left-hand side. The minus 12 is already on the right, and the 6, which was multiplying as the coefficient on the left, comes across and divides on the right-hand side. And now I can evaluate this, and my solution is x equals minus 2. Remember, I can verify that my solution is correct using some substitution. Type in the left-hand side into your calculator. 6 times minus 2, that gives you minus 12, plus 1 is minus 11. So we're correct. Okay, let's go again. If you're feeling confident this time, it might be a good time to pause the video at this stage and try and work through the solution yourself and see if you can get all the way to the end correctly. Okay, so I want to get like terms together. Minus 4x can stay on the left. 11 is already on the right-hand side. The 3 comes across. It was adding, so now it's subtracting. So I've got minus 4x equals 8, and now I'll keep the x on the left. The 8 is already on the right-hand side. And just notice how minus 4x was the coefficient, sorry, minus 4 I should say, was the coefficient of x in this line. So when I bring that across, I'm dividing by minus 4. And then simply evaluate 8 divided by minus 4. You can do this in your head or on the calculator if needs be. If you're doing it in your head, watch out for the rules of signs. They're the same for division as they are for multiplication. So a positive divided by a negative gives you a negative. So my solution for x is x equals minus 2. And I'll just verify that that solution is correct. So I'll type in the left-hand side of this equation down here. Minus 4 times minus 2 comes out as plus 8. Plus 3 gives me 11, so I'm definitely correct. So x equals minus 2 is definitely my solution. Okay, let's do one last example for this video. So here we have 5x plus 2 equals 10. Okay, so same as before, get your like terms together. And again, this is a good opportunity to pause the video here and try this yourself. Okay, so I'm going to keep 5x on the left. The 10 is already on the right. The 2 comes over and subtracts. I tidy up and I get 5x equals 8. I want to get the x by itself, so I run the x on the left-hand side. The 8 is already on the right, and the 5, which is the coefficient of x, comes across and divides. Now, in all our previous examples, our coefficient divided nicely into the number on the right-hand side. That doesn't always happen. It happens a lot in the book, but it's completely acceptable and normal to get fraction answers as well. So just to point out, fraction answers don't mean that you're incorrect. They're quite possible. And there's a couple of ways of presenting my answer in this case. I can write it as 8 over 5. Can you remember the name that I give to this type of number? So it's an improper fraction. It's fine to leave your answer like this. You could also write your answer as 1 3/5. Again, can you think of the name for this type of number? This one's a mixed number. Or you could write it as a decimal, in which case you could write it as 1.6. Any of these are totally fine. As always, we can verify our solution. I'm choosing to use the 8 over 5 as my value to substitute in. You could put in 1 3/5 in for x or 1.6 in for x, either if you like. They'll all give you the same result. So 5 times 8 over 5 plus 2 into the calculator. Press your equals, it gives you 10, so your statement is correct. So 8 over 5 or 1 3/5 or 1.6 are the solution for x. And just to point out the obvious, these are all worth the same amount.